Hello math learners! In this video, we are going to learn about the measures of central tendency. So let's begin. When we say measures of central tendency, it is a measure indicating the middle of a set of data. It is also a quantitative representation of the set of data under investigation. And the most commonly used measures of central tendency are the mean, median, and mode. Now, since we are talking about data here, there are two kinds of data. We have ungrouped data versus the grouped data. When we say ungrouped data, it is a raw data. It is the data you first gather from an experiment or study. It is also a data that is not yet sorted into categories, classified, or otherwise grouped. Usually, ungrouped data has less than 30 values. So that means if you are given a set of data that has less than 30 number of values, that data is considered as an ungrouped data. While grouped data is a data that has been organized into groups, and group data usually has more than 30 values. It's like 30 or more than 30 number of values. Now, let's discuss the measures of central tendency of ungrouped data. So these are the three measures of central tendency of ungrouped data. We have the mean, median, and mode. When we say mean, it is the sum of the data divided by the number of data. When we say median, it is the middle value of the set of data, provided that the data are arranged in an array. When you say an array, it is an arrangement of values either in decreasing or increasing order. And the last one is mode. The mode is the number which occurred most frequently in the data. So now let's discuss how to find the mean of ungrouped data. The mean for an ungrouped data is the sum of the values in the set of data divided by the number of values added. In symbol notation, the formula for the mean of an ungrouped data is this one. This symbol means the mean, while this one means the sum of the measurements or values, and n means the number of measurements or values. So the formula is this: mean equals the sum of the measurements or values divided by the total number of values. Let's try to apply this formula in our examples. Number 1. Find Totti's average grade or mean for the 4 grading periods in Mathematics 7. So we are given here Totti's first grading grade, which is 84, second grading 86, third grading 86, fourth grading 91. And we are asked to find the mean or the average. When we say mean, it also means average. So first step, write the formula. Next, we will substitute the given. So for this one, the sum of the values. So we will write all the values, 84 plus 86 plus 86 plus 91, divided by the total number of values. And if we are going to count them, they are 4. So that means there are 4 number of values. Now let's simplify. 84 plus 86 plus 86 plus 91, it is equal to 347 divided by 4, and that is equal to 86.6. So that means the mean for the 4 grading periods of Totti's grade in math is 86.75. Another example. The following temperature readings were recorded in Tokyo, Japan on one winter day. Let's find the mean. So these are the temperature readings in Tokyo, Japan. So let's try to find the average of these measurements. So first, formula. Mean is equal to the sum of the values divided by the number of values. Next, we are going to write the given negative 1.9 plus 3.2 plus 28.7 plus 5.4 plus 2.0 plus negative 1.2 divided by the total number of values. We have 1, 2, 3, 4, 5, 6. So n is equal to 6. Now, let's add negative 1.9, 3.2, 28.7, 5.4, 2.0, negative 1.2. If we are going to add them, the answer is 36.2 and then divided by 6. 36.2 divided by 6 is equal to 6.03. Make sure to round off your answers to the nearest hundreds or 2 decimal places. So, our answer, the mean for the given set of data is 6.03. Now, last example. The scores of 9 students in Mr. Anderson's class are 64, 59, 63, 60, 65, 66, 66, 61, and 76. Find the mean. Again, the formula for the mean is the sum of values divided by the total number of values. So let's write all the values. We have 64 plus 59 plus 63 plus 60 plus 65 plus 66 plus 66 plus 61 plus 76 divided by n. So we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 students, so there are 9 scores. Now, let's add. The sum of these values is 580. Divided by 9, it is equal to 64.44. Round off to the nearest hundreds or 2 decimal places. So that means the answer is 64.44. Now, let's discuss how to find the median of ungrouped data. The median is the middle value of a set of data when the values are arranged in ascending or descending order. Half of the values are above the median and the other half are below the median. The median is denoted by the symbol and it is not affected by the extreme values. In finding the median, it is important to remember the following. The data must be arranged in ascending or descending order. And if there is an odd number of values in the set, the median is the middle value. But if there is an even number of values, the median is the mean of the 2 middle values. So let's have examples. So we will still have the same examples, but this time we will solve for the median. So again, these are the grades of Dottie for the 4 grading periods, 84, 86, 86, and 91. Again, the median is the middle value, but make sure that in finding the middle value, we need to arrange the given values in order. So it's either in ascending or descending. So let's try to write first. We have 84, 86, 86, and 91. So these are Toti's grade. We need to arrange them in order, but as you can see, they are already in order from 84 to 91. It is in ascending order. Now, we have here two middle values, 86 and 86. If there are two middle values, we need to add the two middle values and divide it by 2. So this will become the median. This is the symbol for median, is equal to 86 plus 86 divided by 2. 86 plus 86 is equal to 172 divided by 2, and that is 86. So that means the median for the 4 grading periods of Toti's grade is 86. Example number 2. So again, our next example are the temperature readings in Tokyo, Japan. So first step, we need to write down negative 1.9, 3.2, 28.7, 5.4, 2.0, and negative 1.2. Next, we are going to arrange them. Let's arrange them in ascending order. So we have 1.9 followed by negative 1.2 followed by 2.0, next 3.2, next 5.4, and the last one is 28.7. We have arranged them in order already, so let's count 1, 2, 3, 4, 5, 6. So there are 6 reading temperature. So since there are even number of values, there are 2 middle values. We have 2.0 and 3.2. To solve for median, we are going to add 2.0 plus 3.2 and divide the sum by 2. 2.0 plus 3.2 is 5.2. Divided by 2, the answer is 2.6. And for the next example, we have the scores of 9 students in Mr. Anderson's class. So again, first, we need to copy them. 64, 59, 63, 60, 65, 66, 66, 61, and 76. And then we will arrange. The lowest value is 59, followed by 60, followed by 61. Next is 63. Next is 64. Followed by 65, and there are 2 66, and then the last one is 76. Okay, next we need to find the middle value. Since there are odd number of values, there's only one middle value, and that is 64. So that means the median is 64. We are done discussing the first 2 measures of central tendency, which are the mean and the median of ungrouped data. Now let's discuss how to solve for the mode of ungrouped data. When we say mode, it is the value that occurs most frequently in a data set. The mode is denoted by this symbol, and we can classify a set of data according to the number of modes. So these are the classification of data according to the number of modes. First, unimodal. It is a set of data with one mode. Next, bimodal. It is a set of data with two modes. Trimodal, a set of data with three modes. And the last one is multimodal, which is a set of data with more than three modes. And if no value occurs more than once, the data does not have a mode. So there are instances that the given set of data has modes and doesn't have modes. Okay. Example number 1. Again, we will still be using the same example, but this time we will be finding for the mode. So these are the grades of TOTIS. We have 84, 86, 86, 91. Again, mode is the number that occurs most frequently. Based on this given, the number that occurs most frequently is 86. So that means the mode is 86. And what kind of data is this according to the number of modes? Since there's only one mode, this set of data is unimodal. Now, example number 2. The following temperature readings were recorded in Tokyo, Japan, and let's find the mode. So again, these are the following given values, and let's try to find a number that occurred most frequently. Okay, as you can see in the given, there's no number that occurred most frequently. All the numbers occurred once only. So that means this data has no mode. Next, number 3. The scores of 9 students in Mr. Anderson's class are 64, 59, 63, 60, 65, 66, 66, 61, and 76. Let's find the mode. So, as you can see, we have here 66. It occurs 2 times in the given set of data. We have 266 here. So that means the mode is 66 and this is unimodal. Another example. We have here different sets of data. So we have here our first set of data. We have 1, 5, 8, 2, and 7. As you can see, there's no number that occurred most frequently, so that means this data has no mode. Next, 1, 5, 8, 2, 8, 7. 8 occurs 2 times. So the mode is 8 and it is unimodal. Next, we have 1, 1, 5, 8, 2, 8, 7. We have 2 modes here, 1 and 8. It's because they both occur 2 times in the given set of data. So our 2 modes are 1 and 8, and this is bimodal. Next, 1, 1, 5, 8, 2, 8, 7, 5. As you can see, number 1 occurs 2 times, also number 5 and number 8. So that means there are 3 modes, 1, 5, 8, and this is trimodal. Next, 1, 1, 5, 8, 2, 2, 8, 7, 5. Number 1 occurs 2 times, number 2 also occurs 2 times, also number 8 and number 5. So we have here 1, 2, 5, 8 as our modes. So this data has 4 modes. So this is a multimodal. Just always remember that if a value occurs most frequently in the given set of data, then that value is the mode of the data. That's all for today, math learners. Always remember, the only way to learn mathematics is to do mathematics.